Hey again, Science 9. I guess the last video, the volume didn't seem to record, so hopefully it works this time right here. Um, so I'll reteach this lesson, I guess. So last time we talked about ionic bond naming. We did ionic bond, just regular binary names. We've done multivalent, and we've done polyatomic, and now we're going to be looking at covalent bonds. So in covalent bonds and how we name things that have covalent bonds, remember covalent bonds are when you have a nonmetal plus another nonmetal. So on the periodic table, that's everything is coming from the right side of the periodic table. Okay, so where your carbon, nitrogen, oxygen, fluorine, sulfur, chlorine, where all those kind of elements are. Now, there are some rules about how to name ionic covalent bonds, and I listed these 4 rules right here. So the first one is name the first element first. Okay, so here we see our first example. So I'm going to name the first element first. I find where S is, and we find where S is, and that's sulfur. And then I name the second element after that and replace the ending with "ide." We should be familiar with how to do that. So here is the second element. So I'm going to go fluoride. Okay, so that's just like our ionic naming. Now we have to add a prefix to each element to show how many atoms there are present. So for sulfur, there is 1 sulfur there. So the prefix means comes before a word. So here's the prefix. 1 is mono, so this should be called monosulfur because there's only 1 sulfur, so we call it mono sulfur. And we have 6 Fs, and so we look up the number 6 right here. And so it's called hexa. So monosulfur hexafluoride. Now the very last rule, and I did this on purpose, says do not put mono on the first element. So we did put mono on the first element, so we just need to make sure to erase that. Okay. Anything else, it's fine, but not mono on the first one. If we had mono on the second one, that's fine. So the name of this, the final name of this is sulfur hexafluoride. Okay. So we're going to do the same thing for this one right here. We have name the first element first. So the first element is nitrogen. Then name the second element second and replace it with "ide." So oxygen becomes oxide. Now, how many are on the first one? Is 2. So that becomes di, nitrogen. And then there is 1 oxygen, so we call it mono. And it sounds funny when you say monoxide, so we just say monoxide. Okay, so dinitrogen monoxide. We do keep the mono or the mon right here for the second element. It's just a rule, don't put mono on the first element. So it stays dinitrogen monoxide. Now we'll do the next one right here. We have S. S stands for sulfur, so we're going to be called sulfur. Cl stands for chlorine. Chlorine becomes chloride. There are 3 sulfurs. So 3 sulfurs is called tri. So tri-sulfur. 4 chlorines, and that becomes tetra. Tetrachloride. So trisulfur tetrachloride. And that is the final answer. So trisulfur tetrachloride. So here you can put the video on pause, try doing a few of these things yourself, and hopefully you come up with this. So going the other way, we see sulfur right here. So I'm just going to write sulfur, S, oxide, I'm going to write oxygen right here, O, right there. Now it says di, we know that di means 2, so it means 2 sulfur, so I need to write 2 sulfur. Dioxide, so I need to write 2 right here. Now it's the final formula is S2O2. Back in ionic naming, you would reduce that down to like SO, but this is not ionic, so do not reduce these numbers. Don't reduce. So just keep it the same, S2O2. Don't reduce that. Anyways, and so that just kind of stays that way right there. Okay, so here we have carbon, so it's going to be C. We have fluoride, so it's going to be F. And it says carbon. We have nothing in the front right here. So since we have nothing in the front, that means there's a 1 right here. Tetra, if you look on the back of your periodic table, because those fancy names are on the back of your periodic table as well, tetra is 4, so it'd be C1F4. Now, just like before, we don't bother writing this, okay? So don't do that. So it's just going to become CF4, okay? Again, for the next one, nothing in front, so that means it just has 1 carbon. Monoxide, that means it has 1 oxygen. And that's the final answer. Here we have hydrogen. And we have oxygen. It says we have 2 hydrogens, so we must write 2 hydrogens. We have 1 oxygen, so we write 1 right here. Again, you don't write that 1, so it just becomes H2O. So that is the technical fancy way of saying water, dihydrogen monoxide. Going the other way right now, we have S2, so we have sulfur. Okay, oxide. We have 2 sulfur, so it's going to be disulfur, tetra, kind of running out of room there, disulfur tetraoxide. Okay, I'm going to try to write a little bit bigger than that last one right here. Here we have 5 phosphoruses, so I'm going to go a little bit, skip a step here and go penta. Penta means 5 phosphoruses. And we have 10 hydrides, and so 10 is deca. Hydride. Okay, same thing for this one here. We have 4 sulfurs. The scientific way of saying 4 is tetra. Tetrasulfur. We don't put ide here, remember. We only do ide for the second element. And then 8 is octa. Octahydride. Now, here is the interesting one right here. We have Al. Aluminum is a metal. This is ionic, not covalent. So it doesn't get any of this mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay, it doesn't get any of those kind of fancy names. It gets that name that we learned before. That's just called aluminum oxide. Because it's ionic. The only things that get these tetra and penta and di and all that kind of stuff naming is things that are covalently bonded. This is ionically bonded, so it doesn't get any of these kinds of names that we're learning today. So I put this one in here just to kind of remind you that ionic get ionic names and covalent get covalent names. So again, put the video on pause, try doing this one, and try to figure out which one of these is first off ionic and which one is covalent. If it's covalent, it gets that mono-di, it gets those covalent style names. If it is ionic, it must get an ionic style name. Okay, so here we have PO3. So here's P right here, and here is O right here. These are both non-metals. So this is going to get a covalent name. I'm going to write COV there for covalent. Okay. The next one is Mg and O. Okay. That is a metal and a non-metal. So that is going to get an ionic name. So I'm going to write ion right there. Here is Fe, and here is O again. Fe is a metal, iron, and O is a non-metal. This also gets an ionic name. We have CCl4, so C is carbon, Cl is chlorine. So this is non-metal and a non-metal, that gets a covalent name. So what I'm going to do first is I'm going to name the covalent things first. Okay, so that's where you have to use the mono-di-tri stuff. So here we have 3 phosphoruses. 3 is tri, phosphorus. The O is trioxide. So it stays triphosphorus trioxide. Now, the next covalent one is the CCl4. C is carbon. It's 1 carbon, so it could be monocarbon, but remember, we don't say mono on the very first one, so it's just carbon. Then we have 4 chlorines, so it's 4 chlorines, so 4 is tetrachlorines, or in other words, tetrachloride. Okay, so we have now finished off all of the covalently bonded ones. So now we're going to do the ionically bonded ones. So here we have magnesium. Magnesium only makes 1 ion, so we can just write that one. Magnesium oxide. Now here's the next one, FeO. Fe makes 2 ions. Okay, so therefore it's multivalent, therefore it must have a Roman numeral inside of it. So I'm going to do the old reverse swap and drop. So first off, I'm going to write Fe2O3. Then I'm going to write Fe up here and O up here. O is 2 minus. Okay. Now, we reverse swap and drop. This 2 came from that 2 right there. Now, this one right here, it could be a 3 plus or a 2 plus. Could be a 3 plus or a 2 plus. Now, since this 2 was linked to that 2, there was no change. This 3 links to this 3 right up here with no change. So, in other words, since we are using the 3 ion right here, it is going to be called iron. Since it's that 3 ion, we go 3 oxide. That was from not last week's lesson, but the week before, how we come up with this stuff right here. So if you're unsure how I did it, try looking at the, not last week's video, but the one before that, and we talk about how we came up with iron 3 oxide. So even though there's a 2 right here, and you want to say it's iron 2, no. It's iron 3 because we used the 3 ion when we came up with this. So try doing the practice sheet. You can do the whole entire practice sheet now. If you have difficulty with it, then message me over Microsoft Teams, and I could try to help you out with that. But other than that, we are now done our chemistry section. So next week we're going to have a little chemistry test, and I'll post that and some practice tests online as well through Microsoft Teams next week. Okay, good luck.